Okay, welcome to 4.7 notes. Let's start off with parts of an isosceles triangle. Remember, an isosceles triangle has two congruent sides, and those congruent sides are called the legs. And so these two congruent sides are called the legs. And the vertex angle is the angle that's included by the legs. Okay? Again, we have the two congruent sides called the legs, and the vertex angle is in between the two legs. The third side is called the base, and included within those are the base angles. And these, and there are certain parts of an isosceles triangle that have certain specific relationships. One of those relationships can be summarized with the base angles theorem. The base angles theorem states that if two sides of a triangle are congruent, then the angles opposite them are congruent. So in this example, if we have line segment AB congruent to line segment AC, as shown with the two tick marks, then that automatically follows then, according to the base angles theorem, that angle B will be congruent to angle C. Right? If line segment AB is congruent to line segment AC, then angle B is congruent to angle C. And the converse is also true. So if angle B is congruent to angle C, then line segment AB is congruent to line segment AC. So if you have these two angles congruent, angle B is congruent to angle C, then the converse of the base angles theorem follows that line segment AB is going to be congruent to line segment AC. Okay, let's work on this little problem here. So we have this figure with vertices A, B, C, D. And if line segment AD is congruent to line segment BD, then what two angles are must be congruent according to the base angles theorem? Well, we have, again, line segment AD is congruent with line segment BD. So that must mean that angle DAB is going to be congruent with angle ABD. So, give me a minute here. That would be, again, angle DAB is going to be congruent with angle AB. ABD. And the next problem is if we have angle BDC is congruent with angle BCD, then what two line segments must be congruent to each other? So if we have BDC is congruent with BCD, then which two line segments have to be congruent to each other? The ones that are opposite those two angles. So this would be opposite angle BCD, and this one would be opposite angle BDC. So it would be line segment BD and line segment BC. So again, line segment BD and line segment BC. I know it doesn't look like it in this diagram, but it's just not drawn to scale. But again, if you know that those two angles are congruent, BDC and BCD, then line segment BD must be congruent with line segment BC. Okay? And we have a new concept. If a triangle is equilateral, then it is equiangular. In other words, if it's equilateral, which means all the side lengths are equal, then it's also equiangular. All the angles must be equal as well. And the converse is true too. If a triangle is equiangular, then it is equilateral. So we can have this diagram here that shows that. So in an equilateral triangle, you can also call it an equiangular triangle and vice versa. All the angles and all the sides will be congruent. Okay, so let's try this problem here. So we have a triangle ABC, and we know that all of the angles are congruent. Angle A equals angle B equals angle C. And we have line segment BC is 10 inches long. We have two problems. Problem A, find the measure of angle A, and B, find the length of angle BC. Oops, I mean the length of line segment AB. Okay, so we need to find the length of line segment AB. All right, so first off, doing letter A, we have the measures of all the angles are the same, so basically 3x is going to equal the total measure of a triangle, which is always 180 degrees. So you would just simply divide by 3, and x equals 60 degrees. So in other words, in an equilateral or equiangular triangle, all of the degrees total 60 degrees. And to find the length of AB, line segment AB, there's really not much to show. The measure of line segment AB is going to equal the length of BC, which is 10 inches. So it's 10 inches. Okay, so our final problem is regarding this figure, and it says to find the value of x and y. Let's start off with finding the value of x, and since we have 2 tick marks each, this must be an equilateral triangle, also then an equiangular triangle, right? So all of these angles must be congruent. So that must mean that we have 3x equals 180 degrees, and so x equals 60. Okay? And then to find y, well, now we know that this angle is 60 degrees, right? And we know that this is a right angle symbol, which means it's 90 degrees. So we have 90 minus 60 equals 30 degrees. So this angle here must be 30 degrees. Okay? And we know that if this angle is 30 degrees, then this angle must also be 30 degrees because they are opposite these two congruent sides, right? And the angles opposite congruent sides are themselves congruent. So we have 30 plus 30, right? We have this 30 plus this 30, that obviously totals 60 degrees. There are 180 degrees in a triangle minus the 60 degrees we already have, and that leaves 120 degrees. So y must be 120. So x is 60 and y is 120. And that's it. If you have any questions, please feel free to contact me at your convenience, and it would be my pleasure to help you out. Bye-bye.